Critical points are points on a function where the derivative is 0 or the derivative does not exist at all. Now, we can be able to find these points, and I'm going to show you how you can find them by working out these two examples. So example 1, determine all the critical points for the function f of x is equals to 2x cubed minus 3x squared minus 12x. So the first step is to find the first derivative of the function. Okay, so step 1, find the first derivative of the function, which means we need to differentiate this function. Okay, now this is a polynomial, which means you can just differentiate it term to term. That will be 6x squared minus 6x minus 12. Okay, now we know that critical points occur where the derivative is 0. So which leads us to step 2. So step 2 will set the derivative equal to 0 and solve for x. Okay, so step 2, set the derivative equal to 0 and solve for x. Okay, all right, so which means by the way, our derivative is f of x, f dash x, which is our first derivative. It's 6x squared minus 6x minus 12. Need more space. Okay, and we are equating this to 0. Okay, now we need to solve for x, which means I can, if you consider this bit here, okay, that's the equation you're going to solve. So the first step is we can divide each of these terms by 6. So if we divide by 6 here, divide by 6 there, divide by 6 there, divide by 6, divide everything, each term by 6, we shall end up with x squared minus x minus 2 is equals to 0. And then what we can do is we can split the middle term, which means you need to find two numbers whose sum is negative 1. We just need to factorize the left part. Okay, so two numbers whose sum is negative 1. Okay, assuming the negative 1 is somewhere there, and whose product is negative 2. All right, the numbers are negative 2 and 1. Now I'm going to split the middle term, which means to rewrite the middle term using these two numbers. And what I shall end up with is x squared minus 2x plus x minus 2 is equals to 0. Okay, remember the goal is to factorize. So we'll go ahead and factorize. We shall end up with x. So to factorize the first two terms, x into x minus 2 plus 1 into x minus 2 is equals to 0. So x plus 1, x minus 2 is equals to 0. And which means that either x is equals to negative 1 or x is equals to 2. Okay? Now, these are the critical points of f of x. Okay? So these are the two critical points of f of x. Okay, so these are the two critical points of f of x. And we can be able to visualize this if you come onto, if you observe the graph that we have here. So this point, actually, if I mark it the other way, this point and this point here are the two critical points because the derivative is equals to 0. Okay, you can see the derivative at this point is equals to 0. And this is when x is equal to -1 and when x is equal to 2. Okay, and those are the points that we have below here. Okay, example 2. A vertical asymptote is a critical point because the derivative does not exist from the definition of what a critical point is. So in this example, we are going to determine all critical points, okay? All critical points of this function. So step 1, we shall start with the asymptotes. So step 1 is to find the vertical asymptotes. So step 1, we are going to find the vertical asymptotes. And you're going to find this by simply setting the denominator equal to 0 and solving for x. So okay, and solve for x and solve for x. So that's the method on how you find a vertical asymptote from your previous experience on functions. So and the denominator here is this guy here. Okay, so you're just going to equate that guy to 0. So x squared minus 1 is equals to 0. By the way, x squared minus 1 can be written as difference of two squares. So x plus 1, x minus 1 is equals to 0, which means that x is equals to -1 or x equals to 1. Now this guys here, these are critical points because at these points the values of x so because at these values of x the derivative does not exist. Okay, so these are critical points because the derivatives do not exist at these points. Okay, so these are critical points of f of x because at these values of x, the derivatives or just the derivative does not exist. Okay, may need more space for that. So the derivative does not exist. Okay, so these are the first two critical points. We need to find others. Okay, remember at these points here, in fact, at these points here, the function does not exist. And these are the points that I'm talking about here. Okay, the function does not exist. Okay, which means if the function does not exist, the function is not continuous, we cannot find a derivative at that point. So they're critical points. Now, step 2, we need to find other critical points, and we need to find the first derivative of the function equal to 0 and then solve for that. In fact, if you look at this function, this is the critical point that we need to find next. Okay, and how do we find it? That leads us to step 2. So step 2, step 2, we need to find the first derivative of the function. Find the first derivative of the function. Now, our function from the top is f of x is equal to x squared minus 4 over x squared minus 1. Let me just check that again. Okay. All right. So, to find the first derivative of this function, we need to differentiate it, which means I'm going to use quotient rule. Now we know that quotient rule states that if y is equals to u over v, dy over dx will be equal to v du over dx minus u dv over dx over v squared. Okay, so we need to plug in those guys here. So my v is x squared minus 1 d over dx of my u, which is x squared minus 4 minus x squared minus 4 d over dx of my v, which is x squared minus 1. All this over v squared, which is x squared minus 1 squared. Okay, let's carry on. We need to simplify this, which means you're going to end up with x squared minus 1 multiplied by 2x, derivative of x squared is 2x, minus x squared minus 4, derivative of x squared again is 2x, over x squared minus 1 squared, which will give me, okay, I need to FOIL the numerator, so 2x cubed minus 2x minus, I'll just leave this in bracket because of the minus, so 2x cubed minus 8x, all this over x squared minus 1 squared. Okay, what I'll end up with is 2x cubed minus 2x cubed plus 8x because of the negative. Remember, this negative is somewhere around here, so you have to be careful with it. Over x squared minus 1 squared. Now, if you simplify this, you'll end up with 6x over x squared minus 1 squared. Well, because this and this cancels, and then just end up with 6x. Okay, so this is our dy over dx. Okay, or the first derivative. I can just write the first derivative, if that makes sense. So how do we find the critical point? We know that the critical point occurs when the first derivative is equal to 0. So that leads us to step 3. So step 3, so step 3 will be set the derivative equal to 0. Okay, so set the derivative equal to 0 and solve for x. Okay, so we need to set the derivative equal to 0 and solve for x, and our derivative is 6x over x squared minus 1 squared. So we know that our derivative is 6x over x squared minus 1 squared, and we need to equate this to 0 and solve for x. Okay, now obviously if you solve for x here, you'll end up with 6x is equals to 0, because x squared minus 1 squared multiplied by 0 will just be 0, which means x will be equal to 0. Okay, so we have this critical point here. So we have this point, which is a critical point, and we have two others that we calculated. We have this one and this one. So we can put these solutions together and say that the critical points are x equals to 1, x to negative 1, and x equals to 0. So we can say, hence, the critical points of f of x are x is equals to 1, x is equals to negative 1, and x is equals to 0.